All right, we finished up our first big project with Go. Hopefully at this point you're starting to get a little bit of a hand on some of the common syntax in the language. In this video, I want to do a quick review on some of the highlights of our project, but I also want to point out some things that still look really mysterious and some areas that I want to dive into and do a real deep examination in the next couple videos. So let's take a look. I'm inside of our deck.go file. Inside of here, we lead off with the same statement every time at the top of every file inside of our working directory, which is package main. We then list out all the different imports that we need, or all the different packages that we want to get access to inside of this file. In this case, we needed a lot of different packages to put this project together, so we place the import statement one time, a set of parentheses, and then we list out all the packages that we want to get access to. And you'll notice that we are not separating them by any commas or anything like that. The entire purpose of this file was to write out some code that describes exactly what a deck is and how it behaves. We first started off by creating a new custom type inside of our program, and that is a type deck. The type deck is essentially kind of a thin layer or a kind of an abstraction of sorts over a slice of string. So our deck essentially behaves like a slice of string, but we now have the ability to tie some additional functions specifically to anything that is of type deck. We immediately saw our first example of that with the new deck function right here. We had said that anytime someone calls the new deck function, we will create a brand new deck from scratch and then return it. We specifically labeled that the new deck function returns a value of type deck by placing the word deck immediately after the function name. One of the other very important things to understand around this deck thing and this entire custom type that we set up was our ability to put together a receiver function, or a function that accepts a receiver. And a great example of that was this print function right here. Right before the function name, we added on a receiver of D, which is of type deck. By adding on this receiver, we then got the ability to call on any deck the print function. So right here, if D is a type deck or a value of type deck, we were then able to call a method of print on it. You'll see receivers like this very commonly throughout all Go code that you ever see. And even when we were looking at some of the documentation, we saw a couple examples of receivers already. We also played around with slices a whole bunch. So we saw that slices can generally be thought of or accessed in a very similar fashion to arrays that you've seen in other languages. But we also saw that slices clearly have some advanced features about them. So like we saw the ability to select a range within a slice by using a colon inside of the usual array accessor square brackets. We were able to use that range selector to pull out just some subset of a slice. Now, to be 100% clear, there are several other critical differences between slices in Go and traditional arrays in other languages. But hey, don't worry, that's part of the stuff that we still have to figure out. Now, there is one or two weird things that I want to point out to you about the project we just put together. And one of them was actually very specifically around this deal function right here. You'll notice that many other functions we put together, we set up a receiver of a deck. But for some reason with deal, we chose to take in a deck as an argument. So why did we not choose to use a receiver here? Well, to be honest, the real reason is that if we added in a receiver, there might be a little bit of ambiguity in what this function does. Because I want you to imagine for a second, if we had added a receiver to this deal function and we did not receive the deck as an argument, so if we said something like ddeal like so, or excuse me, ddeck, we would then call this function by doing something like cards.deal, and then we would pass in our hand size. Now, if we wrote out a function with this type of form right here, all of a sudden it starts to get a little bit more confusing than how it was before. And let me really clearly outline why that's the case. When you see cards.deal5, when I personally see this code right here, it immediately makes me think that we're going to take 5 cards out of the deck slice and return them in a new slice. And so my expectation there would be that we modified the slice cards right here. Like if we had called cards.deal and we returned 5 cards, I kind of feel like this card slice would have been modified and there would now be 5 fewer cards inside that slice. And so that is not, that's just kind of, there's nothing about the receiver here that necessarily requires that or anything. I'm just saying that if I saw a function that looked like this, my expectation would be that we are kind of modifying this underlying list of cards. And that entire discussion of whether or not we are modifying that underlying array is really at the heart of one of the next big discussions I want to have. Very closely tied to that discussion is also inside of our deck test file. Inside of here, we wrote out a couple test functions, and then we received in a value, which we referred to as t, and we had said that it was of type star testing.t. And so this star thing right here seemed really mysterious, and it probably seems like something that we should really follow up upon and get a better sense of. So I'm going to tell you right now that this star thing right here, and this question of exactly why we structured this deal function right here the way we did, is really at the core of the next concept that I want to talk about. So at this point, let's take a quick break. We're going to continue the next section, and we're going to start to dive into one of the more tricky topics around Go. So quick break, and I'll see you in the next section.